Hi dear students, how are you? I hope you're fine. Today we're going to talk about very interesting lesson. It's called Trigonometric Ratios. So let's start. Today we're going to talk about sine, cosine, and tangent of an acute angle by using trigonometric ratios. Remember that we have learned before by here the AA similarity, angle and angle similarity postulate. What's this talking about? If I have here two angles that they are here um, equal to the corresponding here angles in the other triangle, so we have here what we have here similar triangles. So here we have the three triangles are similar, right? Okay, this is the first point. When we have here similar triangles, so that we have here what? We have here proportional relationships. Remember when we said before BC over AC, it's the same as what? In the other triangle here, which is similar to the previous triangle, EF will be what? Yes, will be equal, will be here BC over AC equal to EF over DF. And so as YZ, as you see here, YZ over XZ. So this is a trigonometric ratio, is a ratio of two sides of a right triangle. So let's see together. Okay, when we have here something very easy. We have here a right triangle, guys. Okay, in this right triangle we have such some here segments. We will call it segments now. We have here the segment which is opposite to the segment which is opposite to the right angle. We see here angle C, it's a right angle. This segment is called what? We know hypotenuse. So this is the first thing. Please concentrate here. This is the hypotenuse, okay? If I have here, as you see here, a right angle, so this here side which is or segment which is opposite to the right angle, we call it what? Hypotenuse. So this is very important. Okay, we have here what? We have here, if I'm talking here about this one and this one, we have two other here segments or legs. So they are the legs of the triangle. Remember, we have taken this before. So the adjacent leg is what? If I am asking about angle C, for example, so the adjacent leg is the segment between the right angle and the angle which I asked for. So this is what now? This is the adjacent. So I have here, where is the opposite angle? The opposite angle here, it's the angle opposite to the, yes, it's the side here. The opposite side, I mean, it's the side opposite to the angle required. So this is what? This is the what? This is again the opposite leg, and we call it opposite leg. Okay, so this is very important to know, and when we solve like this, I have to write the hypotenuse and the opposite and also the adjacent. Okay, today we're going to talk about sine, cosine, and tangent. What are you talking about? Okay, my dear students, we have here what? We have a rule we have to follow, and it's very easy. So let's see together. Okay, the trig functions can be summarized using the following here. Okay, letters. We can say sukatua. Sokatua, yeah, it's not Chinese, but it's very easy to study or memorize here the sine, cosine, and the tangent by using here sokatua. Sokatua means what? Here, when I say sokatua, I mean, let's see together. Sokatua here for, we have here for soa. What's soa? It's a sign equal opposite. Opposite. O for opposite. This is important. And H for hypotenuse. So it's easy to study this by using the sohakatua. Sokatua. Okay, it's a little bit difficult to memorize this word, but we have to. Sokatua. Okay, sine. We have opposite over what? Hypotenuse. Ka, cosine equal adjacent over hypotenuse. Here A for adjacent and H for hypotenuse. Tangent or tan, we say opposite over adjacent. Okay, guys? So this is very important. This is the most important thing in our lesson today to study this word. Okay, SOHCAHTOA. SOHCAHTOA here means what? Sine opposite over hypotenuse. Ka cosine equal adjacent over hypotenuse, and toa for tan or tangent equal opposite over adjacent. Is it easy now? I think it is. Okay, guys, so we can use today the calculators, so get ready. Okay, we have here the sin, the sign for the sine, and here just cos for the cosine, and tangent for tan in the calculators. Okay, they are abbreviated, as you know. Okay, let's see. Okay, now coming the questions now. Finding trigonometric ratios. Write the trigonometric ratio as a fraction and as a decimal rounded to the nearest hundredth. Sine j. So let's here concentrate. So here he asks me for sine j. Okay, we have here sine j. How can I do it? The sine, okay, the sine here of an angle is equal to what? Remember, we have here opposite leg over hypotenuse. Okay, where is the angle? We have here the angle, as you see here, j. Where is the opposite angle? The opposite angle here, the opposite side here, or leg, the opposite leg here. Okay, we call it here leg instead of side. So the opposite leg here is 60. So we have here 60 over the hypotenuse. Where is the hypotenuse here in my? Please write here opposite to make it sure that you understand it. Where is here the hypotenuse? The hypotenuse, remember, it's the side which is opposite to what? Opposite to the right angle. So 61 here is my hypotenuse, and it's very easy, guys. So it will be like this. So sine here, as you see, sine here of sine j will be 60 over 61, and here we are using now the calculators, but we have to round this to the nearest hundredth, so it will give you what? 0.98. Now he asks me about the cosine of j. So it's very easy, guys, to bring it, okay, by using the rule. The cosine of an angle here, j, this is the angle, okay, it's the adjacent leg over the hypotenuse. Where's here the adjacent leg? Okay, guys, remember the hypotenuse here, it's the side which is opposite to the right angle. So you have here the hypotenuse 61. So down 61. What about the adjacent angle? Okay, the adjacent angle here, it's it's the space. Remember the space or the segment between the angle and the right angle. So this is now the adjacent angle, right? So we have here, as you see, it will be 11 over 61 by using the calculators. It will give you here 0.18 after rounding to the nearest hundred. Okay, here he asks me about 10k. 10k, it's very easy to bring 10k by 2a. Remember 2a, it will be what? Opposite over adjacent, right? So here 2a, opposite over adjacent. Where's the opposite here in our diagram? He asks me about 10k. Remember 10k, opposite. What is the opposite here? What do you think, guys? The opposite angle, the opposite leg. So it's the side or the leg which is opposite to which is opposite to my angle, required angle. So here, opposite over what? Remember, my dear students, opposite over adjacent. So where's the adjacent here? So the adjacent here, what do you think? 60 or 61? Of course 60. Why? Because 61 here is the fixed hypotenuse. Why, Miss Dina, fixed hypotenuse? Because it's opposite to the right angle. And here, by rounding after calculating, by using the calculators, we are going to here round to the nearest hundred, so it will give you 0.18. Okay, by using here the calculator, there is something Okay, there is something very important here to mention. Please be sure that your calculator in the mode here, degree is mode, not radian mode. Okay, guys. Okay. So the results here, if you here, I want you to check this. If you use your calculators to find trigonometric here ratio round to the nearest hundred, so you have here the sign of 52 will give you here on your calculators like this to the nearest hundred. So I'm going to here when I say to the nearest hundred, so I'm going to look at here the tenth, and you've got here I'm going to look here for the nearest to the nearest thousandth. Okay, we have here tenths. Okay, this is tenth, hundredth, and this is thousandth. So I'm going to look at this 8 greater than 5, so it will give here the other 8 here for the hundredth. It will be 79, and instead of what, instead of 78. So when he asks you to look to round to the nearest hundred, look at the at the digit before this, which is thousandth with th in the end. So it more than 5, it will give here the 101. Okay, guys, we have here a very interesting question. Find the length round to the nearest hundredth. The length of what? He asks me here. The length of BC. Here, this one. So, how can I find this? What do you think? We have here what? We have here angle B. And we have here what? And we have here this side. This side leg of the right triangle is called what? Remember, it's the opposite, right? It's the opposite here side. So we have got here opposite side. Okay, and we have got here what? We have got here an angle. Okay, so I need here to know BC. BC is called what? This is the angle and this is the right angle. So this is called what? This is called the adjacent leg. So you have O and A. You have here, remember, O and A. So I'm going to use the tangent. Excellent. So I'm going to use the tangent as here the tangent. Okay, guys. When we have O and A, we use the tangent. Why? Because we have here the trigonometric ratio is tan B equal opposite leg over adjacent leg. So I'm going to use this. Okay, then substitute for the given values. So you've got here, guys, tan B, I will write tan B equal opposite leg. Where is the opposite leg here, guys? Which is AC. It's 10.2. It's 10.2 over BC, which I don't know here. Okay, this is easy now. I need to know the value of BC. What should I do to know the value of BC? Okay, so I'm going to also substitute for the angle. He asks me here, guys, the angle, it's what? Angle B is 15. So instead of B, I will write this 15. And instead of the opposite, I will write here, guys, 10.2. It's the opposite here for angle B. And also we have BC, which I need to find. So what should I do here? I need here BC. What's the inverse here to get here BC? So I'm going to do what? I'm going here to multiply both sides by BC. I'm going to multiply both sides by what? By BC. So if you multiply this side by BC and this side also by BC, you got BC here in this side, okay, and we have cancelled here this BC like this. BC over BC gives me just 10.2. BC here, okay, we have got here another thing. Don't forget, okay, I will write it for you to make sure no one get confused here. 10.2 over BC. So I multiplied first of all BC by both sides. So I got here what? I got here BC 10, 15 equal 10.2. Okay, then I need what? I need just BC alone. So over tan 15 over tan 15. Tangent, I mean. Okay, so we have got here tangent 15 goes with tangent 15. Here, leave, okay, BC is left alone. I get the value of BC alone. So BC equal 10.2 over tan 15. By using the calculators, you will find here, by simplifying, it will be BC 38.07, okay, to the nearest hundredth. Okay, very important note we have here. If you know the sine, cosine, in the tangent of an acute angle measure, you can use the inverse trigonometric functions to find the measures of the angle. Okay, so if we know here this, if the sine A is x, then sine negative 1x equal measure of A, the inverse, and so on here. So we can use the calculators to find each angle to measure to the nearest degree. Okay, so let's start this. Okay guys, this is only to show you how to use the calculators for the inverse of the sine and cosine and the tangent. Okay, as you see, to check your understanding by using the calculators. So let's solve here. Find the unknown measures, round length to the nearest hundredth, and angle measures to the nearest degree. Okay, how can we solve this? We are going to use what, guys? We are going to use the Pythagorean theorem. It's very easy here. We have here what? We have here this side 5.7 and 5, and this is the missing one. So remember the Pythagorean theorem, it's very easy. RT to the power 2, okay, this side, RT to the power 2, it's equal to RS to the power 2 plus ST to the power 2. And we're going to use the calculators, so don't panic, it's very easy. So we're going to have here, substitute here, and instead of RT, write 5.7 power 2, and instead of here 5 power 2, and instead of SR, it's 5 power 2 plus ST power 2. And then what we are going to do, so ST will be what? After finding this, 5.7 power 2 equal 5 power 2, 5 power 2. Okay, let this go to the other side by negative sign and solve it. So I need here to know just ST. We have ST power 2, and we have here, okay, and we have here 7.49. So how can I find ST alone? The inverse of the square is what? The square, the inverse of the square is square root. Remember this, square root. So I'm going to have the square root of what? 7.45. So it gives you 2.74. Okay. After that, he asks me about something very important, guys. I have here what? I have here angle S. How can I find here this angle T and R? Okay, T and R, so I'm going to have, if you have two angles, so I can get the third angle. But now I have just one angle, which is 90 degree. And this is not a special triangle. We don't have 45 and 45, 30 and 60 angles, no. So what should I do here? It's very easy. We have here what? As you see, we have here we can get the value of angle R. It's easy by using what? Okay, angle R here, it has, okay guys, we have here something very important to mention. Remember this word very much. Sohkahtoa. Okay, I have here what? I need to know the angles. So we have here the hypotenuse, okay, as you see 5.7, this is mentioned, and we have also the adjacent, okay. So I can get here by using the cosine of R. The cosine of R, as we know, the cosine here, ka equal adjacent over hypotenuse, right? So can I use here the inverse of the cosine to get here the angle of R? Yeah, so I'm going to use it the same here, but here by using the calculator, negative to the power negative 1. So I'm going to do the same here steps, but this time instead of cosine here, I will use cosine negative 1. This means the inverse of the cosine, and if we do it, you will find it will be 29 degree. The last thing here, when we get this angle, okay, so you can get the third angle of 180 minus 90 minus 29, so you get the last angle here will be, which is angle T, 61 degree. I hope you understood the lesson, my dear students. Study well from the PowerPoint presentation and from the videos, and if you have a question, please send me on Google Classroom. Thank you. Bye bye.